TechInFive.
Python in practice, master real-world projects in 5 minutes. Delve into polynomial regression in our machine learning series. Join us to enhance our model with polynomial features for complex relationships in data. Welcome back to our machine learning series. Today, we're diving deeper into regression analysis by exploring polynomial regression. In our last video, we applied multiple regression to the California housing dataset to predict house values based on several factors. Today, we'll enhance our model by introducing polynomial features to capture more complex relationships within the data. Let's get started and see how we can apply these concepts to our ongoing housing price prediction project. In our previous video, we analyzed how several factors, including median income, house age, average number of rooms, and population levels, collectively impact housing prices across various districts in California. This leads us to our next topic, polynomial regression. Building on the foundation we set with multiple regression, we'll now enhance our model by introducing polynomial features. But what exactly is polynomial regression? Let's take a look at the general form of a polynomial regression model. Here, beta 0, beta 1, beta n are the coefficients that the model will learn to optimize, and epsilon is the error term. By adding powers of the original predictor variables, we allow the model to fit more flexible shapes and thus capture more complex patterns in the data. In simpler terms, instead of fitting a straight line to our data, polynomial regression fits a curve, which can be quadratic, cubic, or of any degree we choose. Polynomial regression is particularly useful when the relationship between the independent and dependent variable is inherently nonlinear. It can model curvature and interactions between features that linear models might miss. This can lead to better predictions and insights, especially in cases like economic growth patterns, disease outbreak levels, and more where changes aren't merely linear. First, we need to import the necessary Python libraries and modules for polynomial regression. We'll use polynomial features from scikit-learn to generate our polynomial terms. With our libraries ready, we proceed to load the California housing dataset. As usual, let's take a quick look at our data, which consists of features like median income, house age, and average rooms, all key predictors of house value. Next, we choose relevant features that we hypothesize will predict house values, and split the data into training and testing sets to ensure the model is tested on unseen data. Next, we transform our selected features into polynomial features. This step involves choosing a degree for the polynomial features, and converting our existing features into a new feature matrix with terms up to the second degree, including interaction terms. Second-degree polynomial, which will include terms like x squared, and interaction terms like x1 times x2. With our polynomial features ready, we train a new linear regression model on the polynomial features to capture more complex relationships within the data. This model will now learn to fit not just a straight line, but a multidimensional curve to our data, providing a more nuanced understanding of the dynamics at play. After training, it's time to see how our enhanced model performs. We make predictions on the test set and evaluate the model's performance using MSE and R². These metrics will help assess how well the polynomial model fits the data compared to the simple linear model. A lower MSE indicates a better fit of the model to the data. In this case, the polynomial regression model has a better fit and makes fewer errors on average in its predictions. A higher R² value indicates a better fit of the model to the data. In this scenario, the polynomial regression model captures more complexities and relationships in the data. Finally, let's visualize the actual versus predicted values. This comparison will highlight the precision of our polynomial regression model. Overall, these results suggest that the polynomial regression model provides a more accurate and fitting representation of the dataset, making it a preferable choice for this particular prediction task. Thank you for joining us in exploring the power of polynomial regression. Don't forget to like and subscribe. Keep exploring, keep learning, and see you in the next tutorial.
Stay tuned for more videos on TechInFive.